In this section, we zoom out from verification and focus on issuance. You'll see how an issuer discovers wallet capabilities, offers a credential, authenticates the user, and delivers it into an EUDI wallet. We'll also connect these flows to KYC processes today and to lifecycle attestations as your ecosystem evolves. You've already done the strategic heavy lifting. You understand why EIDAS 2.0 exists, who the actors are, and how onboarding and KYC requirements translate into architecture. You've aligned GDPR, AML, and audit needs with privacy by design controls and shaped end-to-end onboarding and credential lifecycles. In the last topic, you focused on verifiable presentations and OIDC4VP. Now we move earlier in the journey and look at how credentials are actually issued into the wallet using OIDC4VCI. In a presentation-centric KYC journey, it's easy to focus only on OIDC4VP, how a wallet proves things to a verifier. But that proof is only as strong as the credential that entered the wallet in the first place. OIDC4VCI defines that issuance path. When you understand issuance, you can reason about credential quality, trust chains, metadata, revocation, and renewal. And remember, once onboarding completes, your own platform may act as an issuer as well. OIDC4VCI connects four main players in digital identity. The issuer exposes standard OpenID endpoints so a wallet can discover what it can issue, get authorization, and obtain tokens and credentials. The user or holder stays in control, approving what is issued into their wallet. Later, a relying party asks for proof. Through OIDC4VP, the wallet presents selected credentials, and the verifier checks them using familiar OpenID and OAuth security concepts. A credential offer is the handshake that starts issuance. It tells the wallet who the issuer is, what credential profiles are available, and how to continue. That message might arrive through a QR scan, a deep link, a browser redirect, or a back-end triggered push. The offer can kick off an authorization code flow or use a pre-authorized code, and it can bundle multiple credentials. Whatever channel you use, integrity and anti-phishing protections are critical. You can think of the credential offer as a structured invitation. It identifies the issuer, lists available credential configurations, and states which grant type is allowed, plus any transaction context the wallet needs. Designers choose the right grant: authorization code for interactive flows, pre-authorized code for streamlined or kiosk scenarios. They then align delivery: QR for cross-device journeys, deep links for in-app experiences. Throughout, they minimize personal data and enforce replay and tamper protection. Before a wallet asks for any credential, it first discovers what the issuer can actually do. It calls a well-known metadata endpoint and receives a structured document describing the issuer's authorization server, token, and credential endpoints, and any notification channels. The same document lists supported credential formats, cryptographic algorithms, and proof mechanisms. By validating this metadata carefully, the wallet can check compatibility and avoid talking to untrusted or misrepresented issuers. Credential configuration is essentially the contract between issuer and wallet. It declares which credential types exist, which technical formats they use, and what claims each one may contain. It also defines how credentials are bound to a subject, for example via keys or device binding, and how long they remain valid. Finally, it controls how everything is presented to users, so a single configuration drives both security behavior and user experience. Despite all the options, OIDC4VCI issuance follows a simple pattern. First, the issuer sends the wallet a credential offer. Next, the wallet learns about the issuer, what endpoints exist, what credential types are available, and which grants are supported. Then the user proves they're allowed to receive this credential, either through a fresh login or a pre-authorized code. After exchanging that for a token, the wallet requests the credential and stores it securely. Authorization code flow is the classic browser-based experience. The wallet sends the user to the issuer's authorization server, the user signs in, consents, and then the credential is issued. This gives higher assurance but adds friction. With a pre-authorized code, the issuer has already verified the user elsewhere. They hand out a code, often plus a PIN, so the wallet can fetch credentials quickly, while still controlling risk and meeting policy. Once authorization succeeds, the wallet swaps its authorization or pre-authorized code for an access token, which it then uses to call the credential endpoint. To stop replay attacks, the issuer can add a nonce, a one-time random value the wallet must echo back. Alongside that, the wallet sends proof of possession, typically a signature with its private key. This lets the issuer bind the credential to that key, not just to any copied token. A credential request is essentially the wallet saying, "I want this specific credential and here's my proof." The issuer then checks everything: authorization, request parameters, the proof itself, and any issuance policies or eligibility rules. If all checks pass, the issuer either returns the credential immediately or signals that issuance is pending. The wallet must then verify the issuer's signatures, bind the credential to the user, and store it in secure wallet storage. Issuance is where trust can be won or lost. Treat the issuer like a critical dependency. Verify their identity, metadata, endpoints, and crypto profile before you accept anything. Keep personal data out of offers, redirects, and logs wherever possible. Defend the flow against phishing, replay, code interception, and misbinding, so credentials always land in the right wallet. Finally, log issuance in a way that supports audits without turning the system into a surveillance tool. Once you've done KYC and trust the customer's identity, you don't have to stop at access control. You can turn that trust into reusable credentials. You might issue an onboarding complete credential, an account ownership attestation, or a customer status badge like verified or eligible. Those artifacts live in the customer's wallet and can be reused across products, channels, and even partner ecosystems, while you take on issuer responsibilities around governance, lifecycle, revocation, and audit. OIDC4VCI gives us a standard way to move trusted credentials into user wallets. You've seen how offers, issuer metadata, and a structured issuance flow work together with minimal data exposure. Next, we'll focus on trust and status checks to decide when a presented credential is actually safe to accept.